And all the old but I'll be singing you.
Looks like everybody's getting in. Oh my gosh, you guys. Patrice has lost her mind. She's absolutely lost her mind. I don't know if anyone saw the picture I posted. I don't know if I've talked about it, but I made a squirrel table and I had Mr. Glotz put it up in my backyard. And I put peanuts out every day for Patrice and friends. And yesterday, she decided that she needed snacks immediately. And while I was sitting at my table outside, she decided to hop down onto the puzzle I was doing, pick up a puzzle piece, throw it on the ground and protest, and basically beg for treats. And I was like, this is getting out of control. I was like, there are no treats right now. You need to go away. I shoo her away. She comes up behind me and taps me on the thigh. Toot, toot, toot. A squirrel. This is a human squirrel. I mean, a real living squirrel, a human squirrel. This is the problem. Your teacher has completely lost it. She just called Patrice a human squirrel. Here she is. Can you see this? Let's see. Tapping me on the thigh. That's my leg. Like she's literally sitting right next to me and she's lost it. And I've lost it too. Anyway, so just now I was gonna let you guys into the room and at the back door, hello, where are the morning treats? She's literally back there slapping herself in a bush, like going crazy, like where are the treats? I go out, I'm like, fine, morning treats. I take a couple of peanuts, I walk outside and she runs to her picnic table, sits on the picnic table and is like, okay, where are the treats? And I can't even put it into her treat cup before she's like stealing it out of my hand and running away. I'm telling you, I don't know what to do, guys. This is the worst possible scenario. I completely ruined the ecosystem in my neighborhood by giving one squirrel a couple of treats. And yeah, I think she's told some friends because I'm pretty sure I saw another bushy tail hiding in a bush nearby. In any second, she's going to be back here and being like, more treats, please. Oh, bother. It's going to end badly, guys. Just when you hear on the news about some lady like being attacked by squirrels, in the backyard, or that I just joined the squirrels and now I live with the squirrels. It's just bad. Hello, good morning. Michaela Yamoa, 8:04 in the morning. Great to see you, buddy. Are you actually there, Michaela? You don't have to show us your face. I was just wondering if it was really you. Maybe not. We'll see. Okay, let's see. We've got no one in the waiting room. I think that's good. Oh, we've got someone in the chat. Michaela. Yeah, I'm here. Strange face. But is it really you, Michaela? Is it really? Prove it to me. Say something in the chat. Only I would know. I mean, I can't imagine anyone really wants to bomb AP Bio FRQ practice, but you never know. Wait. Oh, I see, because I hate when kids say wait. I get it. Great. It's the real you. Perfect. Okay. Let's see here. We're going to do some FRQs this morning. Actually, we're going to do two. So get ready. We are going to do two shorties per usual, but the first one is, I think, super duper easy to overthink in part B for sure, but otherwise very straightforward. So you guys should be able to knock that one out in about 10 minutes, I think. And then the second one is a short FRQ. The answer should only take you a couple minutes, maybe 10, but it is like the pinnacle of, this is one that kids will overthink for sure. And like stress out about and write, when really it's just so intuitive. So we're going to do those today. Let us put up the first one. The problem with the first one, for some reason, part B didn't attach to it. So I'll throw up the part A, and then I will explain part B to you once we get into our whiteboard. So here we are with part A. Hopefully you can see that. Oh, too much zoom. All right, I'll read it out loud. I know it's a little small, sorry about that. It says, an experiment was conducted to measure the reaction rate of the human salivary enzyme alpha amylase. 10 milliliters of a concentrated starch solution and 1 milliliter of an alpha amylase solution was placed in a test tube. The test tube was inverted several times to mix the solution and then incubated at 25 degrees Celsius. The amount of the product, maltose, present was measured every 10 minutes for an hour. The results are given in the table below. Then it gives you a beautiful table. It's labeled, it's got units. What would I do with a lovely table? Here we go. Graph the data on the axis provided and calculate the rate of reaction for the time period 0 to 30 minutes. This should sound a little familiar if you were here yesterday. So jot it down, or at the very least, jot down some of the main info from the intro, or just, the instruction for what you're supposed to do for number one. Obviously, I'll put the graph or the table back up when you go ahead to, when you start the problem. Try not to start it right now. I know it's super tempting, but we're going to talk about it before you jump in. All right, I'm going to go ahead and shift over to a whiteboard so that we can just talk about how we're going to get into this one. Again, try really hard not to start the problem yet, just so that you can use the time wisely, but I'll go back to that screen in a little bit so that you can finish copying down the table if you haven't already. All right, here we are. Okay, so it's our favorite. We're going to graph. Oh, actually, you know what? Before we talk about what the problem is asking us, let me just give you part B. So, oops, there. Oh. See, again, this is not organized. You better be more organized than me or you're in trouble. Okay, so part B, or I guess it would be 2, right? Because the first one said 1. So 2 is going to be explain why a change, oopsie, in the reaction rate is observed over 30 minutes. Okay, so that's part 2. Part 1, graph and solve for the reaction rate from 0 to 30 minutes. Part 2, explain why a change in the reaction rate was observed over those 30 minutes. Okay, so first things first, in number 1, I want us to graph. For those of you that have been coming to this morning meeting, you are probably getting really familiar with what that means, but let's just go over them again for good measure. So that means we're going to put all the data points on the graph. We're going to label the heck out of everything. Remember that that should include your units as well. And they can be abbreviated. Oh my God, you guys, Patrice has lost her mind. She's literally at the back door. Or I've lost my mind, I don't know. Okay, let's see. That all your increments are clearly represented and scaled. So that means that if you want, to put increments of, for example, the time for this experiment at 10, 20, 30, 40, 50, 60, that you show on your graph on the x-axis exactly where those increments are with like a little line or a dash or something. And then last but not least, adding a title for good measure, which includes the independent and dependent variables. Okay, so that should be a broken record for most of you. Some of you, I can tell, you're not even writing it down because you know this by now. We've been working on it a bunch. Great. That's what we do for graphing. Then it says now I need to look at it. Uh-oh. See, this is what happens. Mustard, where'd you go? This is not good. This is just not good. Oh, there we are. Huh, sorry. Okay, so if we're looking at this for part 1, it says, and calculate. Oh, that's the word today, calculate the rate. So when we go to calculate, that's an easy one. Literally just like you would in a math class. Solve a math problem using a formula. Now, sometimes these formulas are more complicated, right, than just finding the rate of something. They could be more complicated, and remember that you'll get a formula what do you call that, chart? Formula sheet. So that's lovely. However, when you need that formula sheet will be up to you, right, to determine whether or not when those formulas should be used. You don't want to get into the habit of immediately seeing calculate and then going to that formula sheet because you think you're going to find the way to solve the problem. There's going to be plenty of FRQs where the formula should be in your head and you don't need to use, one of the complicated formulas from the sheet. They're not going to give you easy formulas on that sheet. Those are for the ones that, okay, we don't expect you to memorize this because it's insane. Or there's some constant that you need to know or whatever. So don't necessarily calculate, oh, I need to go straight to the sheet. Think about it first. Is this an easy one that I can probably just either do in my head, or I know that it's just x over y equals d or whatever. Okay, and then in part 2, it asks us to explain. So to explain is just to make comprehensible, understandable. It's how or why. It doesn't say describe, it doesn't say story tell, it doesn't say discuss. So don't get crazy, it's just, this is why. One sentence. Remember, this is a short FRQ, and those short FRQs don't usually have discuss or describe or, something really, that they need you to have multiple parts to. They want quick, concise answers. Remember, this should only take us 15 minutes. And if there's a graph involved too, and a calculation, then this explain should just be quick. 1 to 2 sentences max. Okay. I think we're ready to go. Let's see, we've got 8:17. Oh man, did I talk too much? Okay, 8:17, so about 8:27, I will check back in with you to see how you're doing. Actually, I'll probably check in with you. I will leave my, oopsie, no, I won't. I'm gonna switch over to the actual problem so that you have the table if you need it. And then in a couple minutes, I'll put that part 2 back up in case you need it. In the meantime, I'm going to go check on Patrice, make sure she's not tearing down the backyard. Well, you'll be happy to know she's just calmly sitting in the backyard. She's not doing anything crazy, but she's not getting any more treats. I'm just going to switch back over to my whiteboard in case you need part 2. Sadie, are you reading your tea leaves or your coffee grinds?
It's loose leaf tea, so it's just grainy at the bottom.
Yes, 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 yes. What does Harry Potter see at the bottom of his teacup? Is it the black dog? Oh, righty, my dears. Just checking in. It's a little over 5 minutes into it, which of course you would have way more time, but just wanted to see who maybe would like a little bit more time. Just like a hand wave or a shout in the chat or a help. I'm not hearing anything or seeing anything. Oh, there, I see. Lower. Oh, Michaela, that's cool. How'd you do that? I like it, but I'm going to say that you would like a little more time, and I like your little symbol. Lower hand. I'm going to click on it. Oh, great. I put your hand down for you. How weird. How'd you do that? Under reactions? No. I don't know how you get that.
There's like icons like on my iPad. Like if you click on the participants, you can like raise your hand, and now you can put yes, no, and you can put go slower or go faster.
Oh, fancy.
Yeah, they just added that right now.
Go slower or go faster? Is that like?
Yeah.
Speed it up. Got places to be. That's funny. Cool. I don't have any of those, but maybe that's because I'm the host. Huh. Very cool. All right. I'm going to give it maybe 2 more minutes to wrap it up, and then we'll just kind of briefly go over this one. Maybe hear a couple of your part 2s. and your calculations, and then we're going to dive right into our second one. I just want to get through both of these today because I think it's worth it to show you the second one that I think would be easy to overthink. And then I can answer questions on anything, or you can send them to me. So just so that next week when we move forward, we're kind of caught up with Unit 3 FRQs. Anyone been going to the live AP sessions on YouTube? I know we're not quite caught up yet, so it's kind of maybe not time, but maybe next week you'll go. Okay. Great. Let's just go over this one for maybe 2 or 3 minutes and see how we did, how we fared. Where's my cheat sheet here? Oh, there we go. All right. I did some calculations myself, so hopefully we all got something similar. Can someone describe their graph or put it up to the screen and show us or share? Oh, look, there's Sadie's. Beautiful. Anyone else? Same. Xander's saying same. It's a curve. Great. Chanel nodding yes. Okay, great.
Yeah,
so
it looks like that.
Yeah, good, Jayla. So your graph should be a curve. Do I need to connect the points? Most of you are nodding yes. Yeah, great idea to go ahead and connect the points, because we're taking data points over time at whole numbers 0, 10, 20, 30, 40, 50, 60 minutes, right? But presumably the reaction is still happening on the 1, 2, 3, 4, 5, 6, 7, 8, 9 minute, right? They didn't just stop happening. So of course that line is connected. However, guess what? You would not get marked down on the AP if you don't connect those dots. Just a little tip. You can or cannot, it doesn't matter. If you were asked to graph certain points, you did it. So don't stress too much about that, but you guys are well versed enough in your graphing that you know that this trend was continuous so that you can use the connecting line. Okay, great. Looked like when I saw Sadie's at least that she had good labeling of her graph and maybe even a title. So that's perfect. We'll move forward from that because we've been working on graphs a lot. Does someone want to share their calculation? What did you get for the rate of reaction for the first 30 minutes?
I got 0.34.
Great, 0.34. And then Chanel, just tell us, did you have any units that went with that 0.34?
Yeah, I did a little weird U thing, and M, and then with the slash and then minutes.
Perfect, great. So Chanel has 0.34 micromolar per minute. Anyone else want to share their answer, or maybe a thumbs up that you got the same thing? Sadie's the same.
I did 1 mole like per 3 minutes, so I did it kind of like the opposite way, if that makes sense.
I would love to either see it or hear more.
Like instead of doing like 0.3 per minute, I did like 1. I don't know if that works or if that's
0.3 per minute. Okay. So will you tell me just what your answer actually says?
Yeah, so 1 the /3 minutes.
Oh, I see.
Yeah.
I gotcha. So you don't get to 1 micromolar until it's 3 minutes. So yes. Oh, interesting, Xander. Yeah, so your answer, the calculation is still correct. However, I to be honest, if you got a scorer that's being super lazy and they're only going to look at what they're given in their rubric, which in the rubric for this, it's 0.3 to 0.4. That's the range of correct answers. If they're not thinking like, if they're just looking at your number and they see 1, they might be like, oh, you got it wrong. And not realizing that you just, you're doing it in a whole fraction versus a decimal. Does that make sense? Like you didn't reduce it, so to speak. So if they're just being lazy and all they're doing is looking to see if you match the rubric, then you wouldn't get credit, which is a super bummer, even though you're correct. If you have a scorer that's super thorough and is like, oh, I see what he did there, ooh, I'll give him a little half credit or whatever. I'm going to give him a point on that instead of just it's totally wrong. So it just really depends on the score you have. You're not wrong. However, I would just be careful, if that makes sense. So no fractions in your answer, so to speak. Okay, good. Great question. I'm glad we got that out. Okay. So yeah, that's the giveaway there, that the answer is somewhere between 0.3 and 0.4 micromolar per minute. Just make sure that when you are calculating that and then you're expressing your answer, that you just put it in a sentence. The reaction rate for the first 30 minutes of this enzymatic activity is 0.35 micromolar per minute. And you don't have to write out the words micromolar per minute. You can write it as an abbreviated unit. So like Chanel was saying, she said, that funky little U, big capital M with a line, and underneath it, MIN for minute. Okay? Great. Anyone have any questions about part 1? Great. Moving forward. Part 2 says to explain why a change in the reaction rate was observed over 30 minutes. So explain is just a how, or make it comprehensible to me. Why is this graph coming up and changing over time? Why didn't it just constantly have this much reaction rate or go up and stop? What's going on? Why is there a curve? Why does it slowly level off? Anyone want to read their answer? Remember, it should only have been 1-2 sentences max. Sadie, go ahead.
Okay. I wrote, a change in reaction rate was observed over 30 minutes because as the levels of the substrate decrease, the rate of an enzymatic reaction will decrease due to either the product acting as an inhibitor or the decreasing frequency that substrates bind with the enzyme. Perfect.
Great. She gave us a 2 and 1, right? So she could have just said, hey, this enzyme ran out of substrate to use, so it's ending. But she also told us that maybe something was inhibiting this reaction. Maybe something came up and blocked the active site. Maybe the environment changed, the pH changed, something happened and it inhibited the substrate binding to the enzyme and the activity continuing. So perfect. She hit a 2 and 1. She didn't need to, but she did, and she did it all in, I think that was 1 sentence, right? Great. Perfect. Anyone else want to share theirs? No worries if not. I'm just going to read you a couple of the acceptable answers. So run out of substrate, like Sadie said, right? Something inhibited it, like Sadie said. Or the third one could have been that the enzyme itself expired or denatured, that the enzyme has a very fixed longevity, that it can only do its job for a certain amount of time and then it's out. Alrighty, so that one, you could have overthought it because, you're thinking like, oh my gosh, should I be looking for some kind of answer in the graph? Is it something about the 30 minutes? Oh, why are they so focused on 30 minutes? Well, it just happens to be where the graph starts to level out. And they just want you to be mindful that enzymatic reactions can't happen forever, right? Something has to give usually. Okie dokie. Any other questions on this one? Okay, we're gonna switch to the second one. Again, if you're like, oh man, that was it, I hit my capacity for the morning, that's totally fine. You don't have to stick around, but this one's pretty short. I'm just gonna flash it up on the screen. And I'm not even going to really go over some of the key terms in this one, maybe just verbally, but not write anything down. I'll just let you attack it for about maybe 10 minutes at the most. All right, let's see, where'd you go? Stand by, your faces are in the way. 1, 3, where'd you go? Oh, there you are. Okay. Here we go. It says, fossils of a microscopic organism are found in rocks determined to be over 3.5 billion years old. Identify two types of evidence that would help answer the question of whether the organism was photosynthetic. This is a short FRQ. We already said that. But even more notably than that, all it asks you to do is identify. Remember, identify is one of our shortest things. Just point to it in a complete sentence, right? There's a red, yellow, and a blue cup. Which cup is your favorite? That one. That's not a complete sentence. Okay, the red cup is my favorite. Done. That's it. That's how you identify. Don't go overboard. Identify two types of evidence that would help answer this question.
Loving you is what I loving you is not my control, but loving you, I have a soul what's left of my life. And I would die with me, and I would die for you.
Okay, how we doing? Anyone need more time? Seeing some thumbs up. Just holler if you need some more time. Okay, not hearing or seeing any protests, so I'm going to go ahead. Okay, it says identify two ways to, or two pieces of evidence that would, let us know if this is a photosynthetic organism or not. Anyone like to share? Keeping in mind that identify is just point it out. You don't need a because, you don't need a super long sentence, because it doesn't say describe, it doesn't say discuss, it just doesn't say explain, it just says identify. Point them out, that's it. Chanel.
I said evidence that would help prove the organism is photosynthetic is if there were bubbles around the rock of where the fossil was, that would indicate that it released oxygen. And I also said if a test showed that there were structures in the organism that were similar to chloroplasts.
Beautiful, great. So Chanel has pointed out two things that could make it a photosynthetic organism. There's evidence of oxygen in the environment surrounding the organism or the fossil, or there's evidence of some kind of organelle or membrane that looks similar to chloroplasts. Great, perfect. Seemed like a nice concise sentence. Chanel, just out of curiosity, did you write two complete sentences back to back, or did you do it like bullet points or underline or highlight anything?
I just wrote one sentence.
Just one sentence, and then, okay, great. Any highlighting or underlining?
In the question or in my sentence?
In your sentence.
No.
Okay, so that would be the only thing that I would say for Chanel to make sure that her reader for sure knows what she's talking about, that maybe when she gets to oxygen, she underlines it, and maybe when she gets to chloroplasts, she underlines it, right? Just so that her reader, like, oh, thank you for making it so easy on me. You clearly know what you're talking about, and 5. Great, moving forward, you know what I mean? Just make sure that at all costs, it's easy for your scorer to know what you know. Anyone else want to share what they got?
I said like pigments such as chlorophyll or oxygen.
Beautiful. And then Jayla, was that in some kind of complete sentence maybe?
Yeah, I put in a complete sentence.
Perfect, great. And then same thing, maybe like highlight, underline, or 2 bullet points so that your reader knows, but exactly, pigments are great, and then evidence of oxygen. Anyone else?
Can you test for evidence of CO2?
Yes, absolutely.
Okay.
Yep. So different things can happen in the surrounding minerals of a fossil. So the likelihood that we're going to crack open a fossil and then a puff of oxygen comes out or a puff of CO2 comes out of the fossil and we're like, oh, they must have been photosynthetic or not or whatever, that's probably unlikely, right? That's, being able to actually trap the gas itself, unlikely. Possible? Sure, but unlikely. More than likely, scientists, when they crack it open, they look at the minerals surrounding and see if those molecules have been affected by oxygen. So when a molecule is affected by oxygen, it's called oxidation, and it forms oxides. So for example, like let's say the fossil was trapped in a piece of iron. When you open it up, maybe there's a layer of iron oxide around the fossil, showing that that iron was somehow oxidized into a different mineral. And then same thing with carbon dioxide. Does that make sense, Michaela?
Yes, thank you.
Fantastic, you got it. Okay, so you guys were not hung up on that one like I thought you might be, so great, that's good news. But just as a note for anyone else that's watching this later, this one could be an easy one to try to get too wordy with or overthink, like, oh, so how do I find evidence of a chloroplast, or how do I find evidence of, don't worry about that. All you're trying to do is prove that you know about plants. How do I know that something does photosynthesis? Well, I know something does photosynthesis because it needs these things. It needs organelles that have chloroplasts. It has to have pigment molecules like chlorophyll. It probably has a byproduct of oxygen. So, you know, these are the things that your scorer is looking for you to know, not necessarily like how you would find them or what that might look like. You don't need to know the actual experiment behind it. One thing you could have done, which I didn't hear anyone do, but maybe you did, is list what you wouldn't see. Well, if this actually doesn't have chloroplasts, then it might not have done photosynthesis. If this doesn't have any pigment molecules, then it probably didn't do photosynthesis, right? So you could have gone the opposite way too and say what this fossil doesn't have. Sadie.
Would it be good to say like the presence or absence of like pigment or anything?
Oh.
Make it both.
Yeah, I like that wording for sure. Yeah. Great. So the take-home points for this one though were I wanted you more to see that some of your short FRQs could be super short, right? Read it, identify, you've got 2 sentences max for this one. You know, just showing what you know about, you know, photosynthetic organisms. I mean, this one could have taken you what? Some of you probably, it took what, 3 minutes to jot a couple things down about plants and you're done. But it's easy to think like, oh my God, the timer says I still have 13.2 minutes. What should I do with this time? Maybe I should draw a picture of a plant. Maybe I should draw a picture. Maybe I should, nope, don't do it. Submit, turn it in and move on. If anything, spend the time highlighting those words you want your reader to see and then move forward. Everyone good? We didn't go too far over. It's only 8:46. That's pretty good. And our last FRQ meeting for the week. You've got your last video to watch today, and maybe you're finishing up your FRQs that I assigned in class, but otherwise there's a pretty mellow week of just practice, practice, practice. Again, keep yourself super organized, and we'll slowly move into Unit 4 next week. Gosh, it's beautiful weather, you guys. Go enjoy it. Think of me and Patrice. We'll be in the backyard trying not to murder each other. All right, have a great weekend, you guys. Some of you, I guess I'll see you in a little bit in class.
Thank you.
See ya.
Thank you.
Bye.